Hello, everyone, and welcome back. Today, we're going to be talking about factoring a difference of squares. So, essentially, what I mean by that is if we ever have anything that we're meant to factor that's in the form of a squared minus b squared, there's actually a special formula for factoring, which is this formula up here that says that a squared minus b squared is equal to a minus b times a plus b. Now, in order to understand how come this is true and how come we can draw this conclusion, what we can do is we can use the FOIL method on the right side, right? And basically expand the right side and simplify, and we will indeed get a squared minus b squared every time. This formula is also useful if we're ever asked to factor a difference of squares, right? We can always just use this formula in order to do it quickly. So let's look at the first example, x squared minus 1. In this case, a is like x, right? And b is 1. And so therefore, this is equal to x minus 1 times x plus 1. What about x squared minus 16? Well, same kind of thing, right? We take the square root of both and we find the difference and we find the sum and multiply them together. So a minus b in this case would be x minus 4 because the square root of x squared is just going to be x, and the square root of 16 is 4. And then we have times x plus 4. Okay, what about x squared minus 169? So recall that 13 squared is 169. Therefore, the square root of 169 is 13. So this is going to be x minus 13 times x plus 13. All right, what about this one here? 3x squared minus 27. Something a lot of people might be thinking is, how can we do this when 3 is not a perfect square, nor is 27 a perfect square? And that is true. Sometimes we will have to use other factoring methods as well as the difference of squares method to solve some of the problems. In this case, for instance, what we're going to do is we're going to common factor first, and then we're going to use the difference of squares method to fully factor this. So I'm going to factor out a 3, as I notice that both of the terms have a common factor of 3. And then we're going to get 3 times x squared minus 9. And x squared minus 9, well, now that is a difference of squares. X squared is a square, 9 is also a square. So then we can get 3 times x minus 3 times x plus 3, like that. There we go. Now you can see it. Okay. Next one, 9x squared minus 81. So again, we kind of run into a problem here, right? That actually both of these are perfect squares, but we also have the option of factoring before. In this case, I'm not going to, because we do have both of these as perfect squares. The square root of 9x squared is going to be 3x. So we're going to have 3x here. Square root of 81 is 9. So 3x minus 9 times 3x plus 9. Right? So that's one way that we can factor this. Another thing we can do as well that will also work and prevent us from having to common factor later on. Something else we can do as well, right? Because now we would have to common factor out these two 3's from both and that sort of thing. To avoid having to do that in the later step, we can common factor out 9 from the beginning. So 9 times x squared minus 9. And then, of course, that's equal to 9 times x minus 3 times x plus 3. Whereas had we done it the other way and just done the 3x minus 9 times 3x plus 9, then we have to common factor out a 3 from each of those. So then we would get 3 times x minus 3 times 3 times x plus 3. And then we multiply these 3's and get 9. 9 times x minus 3 times x plus 3. And so we actually do get the same answer regardless of which way we do this one. However, common factoring first is usually faster, more efficient, etc. So I do think always common factoring first when you can is a good move. All right, in this one, we have 16x squared minus 9. And so square root of 16x squared is going to be 4x. And the square root of 9 is 3. So it's going to be 4x minus 3. Then 4x plus 3, according to our formula. That. Then for our last one here, the square root of 64x squared is 8x. And the square root of 25 is 5, so 8x minus 5 times 8x plus 5.